Okay, this lesson's about applications of normal distributions. The difference between this lesson and the previous one is actually that in our previous lesson we had standard normal distributions, and now we only have the normal. So what is the difference between a non-standard normal and a standard normal? Okay, well today what we're dealing with is the same shape. They're all normal curves when they're bell-shaped and symmetric. But in a non-standard normal, which unless it tells you it's standard, you have to assume it's not, the mu does not need to be 0, and the standard deviation doesn't need to be 1. Now there is a very specific correspondence between any value in a non-standard and a corresponding z-score in a standard normal. And you have used this formula in the past when we were very first introducing z-scores as a measurement of standard deviations from the mean. And so that formula certainly still applies, and then you can just rearrange it with algebra and take a z-score and find out what the raw score was. However, if you see this note down at the bottom, you actually are not going to have to spend a lot of time doing conversions, because now that we're not just trying to translate the score, but we're looking at probabilities, we're going to be able to use our calculators to help you. And you're going to essentially have word problems in this section. It's an application section, but there are only really 2 types of problems. So you can see how pleasantly short this lesson will be. In the first type of problem, you have to find an area. Now, just as before, we're going to be using the normal CDF to find the area. But when we did a standard normal, we always use mu equals 0 and sigma equals 1. But in this section, since it's not standard, we will just adjust our sigma and mu. So here's an example. The heights of men are normally distributed with a mean of 68.6 and a standard deviation of 2.8. Find the percentage of men who are taller than a shower head that's at 72 inches. So if we do this, then we can say, well, the mean, mu, is 68.6, the standard deviation is 2.8, and my shower head, I'm looking for the group that is taller than, so somewhere there's actually an x value of 72, and I'm trying to find this area, okay? As before then, we'll bring up our calculator, and we're going to go into that second vars, and then we will choose our normal CDF. Second vars, option 2 is that normal CDF. Oh, look, I did this earlier. My lower is 72 because that's where I'm stopping. And then my upper had to be an extreme value, you know, because it goes all the way to the edge. So that's why I've got 1 times 10 to the 99. Mu is 68.6. and sigma is 2.8. So these values, in all of our last lesson, we just left them at 0 and 1 because that was a standard normal. But now we adjust those. And we find that it's approximately 0.1123. 0.1123. So back in our problem then, for practical speaking, what percentage of the men are taller than a shower head at 72 inches? It's about 11%, okay? So 11% of people are going to try to take a shower at that height, would be really annoyed, or 11% of the men. So this is the type of example you'll have to read through carefully and just make sure you identify what the mean and the standard deviation is. I recommend you draw a sketch here, and then you're going to put in your lowers and uppers depending on where that section is. So before we do our other type of example, which is that inverse norm, just reminding you, sketch yourself a graph, okay? Make sure you don't get z-scores and areas confused. Z-scores are going to range from approximately -4 to 4 at the most, but they are a distance from the mean, how many standard deviations. And areas, on the other hand, are regions under the normal curve. Now, since an area always sums to be 1 when we're talking about probability distributions, then when you're finding areas, expect to have decimals, just decimals, 0.2361 or something, okay? Make sure when you sketch your graph, you think carefully about, do I need this area to the right or do I need the area to the left? And if you have a calculator that does not, let you choose right, center, or left, then just know your calculator's programmed to come from the left. Areas are never negative, but z-scores are negative when they are to the left of the mean. Okay, when they're to the left of the middle, then they're negative. Okay, the absolute value of it just indicates how far, and then the negative indicates it's to the left. Your areas, on the other hand, are never negative. All right, let's do our last type of problem, and then we're just going to keep this video nice and short to make up for some others you've suffered through. Only 46% of women satisfy the height requirements for the U.S. Air Force pilots. Now, this doesn't tell us what those height requirements are. There actually was information about that, but I'm trying to get into how do you work the problem they ask. What would be the maximum acceptable height of a woman if the requirements were changed to allow the shortest 95% of women to be pilots? Well, if I want the shortest 95% of women, then I am definitely getting less than my particular value. So I've got 95% here on the left. Now I have the mean, 63.7, and the standard deviation of 2.9. So let's just pull up our calculator and do this. Now this time, instead of finding an area, I'm trying to find a height. So I don't want that little bitty decimal, and that's one thing to know. Just think about it in terms of sense. If the average height is 63.7, then I'm looking at heights that are not going to be too far off from that number. So second vars, this time, since I'm trying to find a value, I do the inverse norm. Now, if it were standard, if I leave this at 0 and 1, it's going to find me a z-score. But if I adjust that 0 and 1, I will just get an original value. So what I know is I'm going to put in 0.95% for my area. And then I'm going to put in the mu they had of 63.7. And the standard deviation of 2.9. And the way I've sketched it then, since it was the shorter 95%, it's to the left. So now I want to paste that. And what I find is that it's approximately 68.47. That's an awfully close rounding. So 68.47, and then let's look at what that means here. 68, I don't know why I wrote it backwards, 68.47 was the value it gave. But the question again was, what is the maximum acceptable height? So I'm going to say that it's about 68.5 inches. Okay, and that would be my answer on that one. Now, sometimes you're going to have some interpretive questions also besides the math. So here's one that is what I mean there. You just have to really think about it and think about what makes sense. In addition to the maximum allowable height, should there also be a minimum required height, and why? Now, rather than you typing in answers, you will have choices to look through. But certainly here, I'm going to say yes, because they need to be able to see and reach everything. Okay, if they're not tall enough to see everything they need to see, or if they're not able to reach everything they need to reach because of their limb length, then that's definitely a problem. And I didn't write out big sentences, but that's what I mean by some interpretive things. You'll have to consider what that means. So you have two types of questions again. You'll have to find the area, or you'll have to find a value. But because these are not standard normal curves, you can adjust the mean and adjust the standard deviation to whatever is given within the problem. And good news, guys, that takes care of this lesson for today. Get in touch if you have questions.